Welcome to the Explainer. So we're all getting ready to let AI assistants onto our personal computers, right? To help us work, to help us create. But that brings up this really big question.
Really think about that for a second. When you've got an AI on your system, supposedly to help you code or write something, what's to stop it from just looking around, peeking at your private photos, your financial documents, your entire digital life?
Well, the good news is the answer isn't just, crossing your fingers and hoping for the best. It's this really clever idea we're calling the AI's digital leash, a way to set some crystal clear boundaries.
All right, so let's break this down. For an AI assistant to actually be helpful, it needs context. It has to be able to read your project files, your documents, your code, and that creates a real dilemma, doesn't it? How do you grant it that access it needs to do its job without basically handing over the keys to your entire system?
The answer comes in the form of a new standard called the Model Context Protocol, or MCP for short. Now, don't let the name intimidate you. A protocol is really just a fancy word for a standard, agreed-upon way for computers to talk to each other. And this one, it's been designed from the ground up to solve this exact problem of safe local file access.
Okay, so how does it actually work? Well, the whole thing boils down to one core concept, defining the boundaries. And the protocol has a specific name for this.
It calls these boundaries roots. A root is just a folder or a workspace that you, and this is the key part, you, the user, explicitly say the AI can access. It's the official line in the sand. The AI is programmed so that it literally cannot cross it.
Honestly, the best way to picture this is like setting up a playpen for a super helpful but maybe a little too curious robot. You're basically drawing a big circle on the floor and saying, look, you can play with anything and everything inside this area, but you are absolutely, positively not allowed to step outside of it. It's that simple, and that's what makes it so powerful.
And what's really cool is how flexible this whole system is. Maybe you're just working on one single project and you only want the AI to see that one folder. Fine. Or maybe you've got a more complex setup with separate front-end and back-end folders. No problem. The protocol handles both scenarios without breaking a sweat. You define the approved play areas and the AI just works within them.
Okay, so how do the AI and your computer actually, agree on these boundaries? It's not magic. It happens through this really simple and totally transparent process called the permission handshake.
Yeah, so instead of a bunch of complicated hidden code, the protocol just uses these simple, standardized messages. For the tech folks out there, it's formatted in JSON RPC, which is just a super common way for web services to chat. But for the rest of us, just think of it as a polite and very, very clear handshake. And this handshake is so straightforward. The AI server basically asks, using a little message called root/list, hey, where are the approved work areas? And your computer, your app, answers right back with the list of folders, the roots, that you've okayed. That's it. It's a completely open and transparent conversation.
But what happens if you change your mind? You finish a project and want to remove access, or you start a new one and want to add it. It's just as easy. Your app just sends a quick little list changed notification to the AI. This keeps the AI perfectly up to date on its permissions instantly. No guesswork involved.
And all of this, every piece of this protocol, is designed to build toward three things that are frankly non-negotiable: your control, your privacy, and your trust.
First, your control. The protocol is designed to make sure you are always in the driver's seat. Your application, the client on your machine, is responsible for getting your explicit OK, giving you easy tools to manage that list of approved folders and, this is huge, making absolutely sure the AI can't even try to peek at a file outside those boundaries.
Then there's the other side of that handshake, the AI's promise. The server has to follow the rules too. It agrees to always ask for the boundaries first. It has to respect the boundaries it's given, period. And if you change those boundaries, it has to handle it gracefully. The bottom line is simple: it never, ever crosses the line. This is the foundation for building a tool you can actually trust.
So when you put it all together, this is not about having blind faith in some faceless AI. Not at all. It's about having a verifiable system. This clear, standardized handshake between your machine and the AI server, that is what creates a real foundation of trust. It's trust that's built on transparent rules and a mutual respect for boundaries. And that leaves us with a final, really critical thought to chew on. As these AIs get more and more powerful, and they will, our ability to control them can't just be based on hope. It has to be baked right into their design, into their DNA. Open, verifiable standards like the MCP, that's how we make sure that digital leash, that control, always remains firmly in our hands.